The heart has always been the soul of the human body, the rhythm that breathes life into us. When a heart condition, such as heart block, makes the heart beat irregularly, it can cause heart failure. In the mid 1900s, numerous doctors, physicians, and engineers took on the responsibility of preserving the right to life of patients with heart block, finally resulting in one special pacemaker, igniting the development of many other life changing medical devices in the years that followed. But the power of the heart has been known even before the creation of the calendar. 460 to 332 BC, two great philosophers, Hippocrates and Aristotle, believed the heart was crucial to the human body. 280 BC, Wang Shuhe of ancient China wrote 10 books on the pulse. Ancient Romans experienced the benefits of treating patients with electric rays. The 17th and 18th centuries marked the era of the first scientific studies. In 1628, William Harvey described his experiments on a pigeon's heart circulation. 1774, physicians drew a connection between electricity and the heart. A year later, one revived an unconscious chicken, placing electrodes, conductors of electricity, on its chest. By the 19th century, they had crude technology, but understanding is far behind. In 1822, Dr. Leibson used electric currents to change the heart rate of a female patient at will. During the late 1800s, English doctor John M. Williams established the basic concepts of modern heart pacing. The early 1900s brought the invention of the electrocardiograph, the very first heart monitor, which had a major effect on understanding of the heart and its workings. The end of World War II led two men, both returning from war, to meet on the University of Minnesota campus. One was Uli Bakken.
I have always had an interest in electronics, and in 1949, medical electronic equipment was just beginning to move into hospitals, and they had nobody to repair this sort of stuff. My brother-in-law and I had decided that maybe there was a business in repairing medical electronic equipment.
In the early 1950s, he began tailoring medical devices to meet the specific needs of his clients. As word and Medtronic's expertise spread, an increasing number of hospitals, clinics, and doctors' offices from all over the Midwest began seeking out their services. The other, Dr. C. Walt Lillahei, newly appointed Associate Professor of Surgery at the University of Minnesota, had decided to pursue research on open heart surgery when he realized that was where his efforts were to go if he wanted to figure out how to keep his remaining heart patients alive. One effect of the war was the boom of new technology suddenly available, especially in the medical field. Lillahei and his team made use of that when they started doing mock operations on dogs. But they weren't the only ones. Physicians and their associates around the world were also using the new technology to their advantage. In 1953, Anderson and Warden in England published their experiments on using controlled cross-circulation to support one of their dogs during heart bypass. March the next year, Lillahei's team started using that technique after witnessing its success. They spent the next 3 years learning from their many varied trials. In 1957, Lillahei was reviewing all the knowledge he and his colleagues had gained from all the operations they had done, when he realized the biggest danger for heart patients wasn't some surgery or treatment, but one of its most volatile effects: heart block. Patients who survived the initial therapy and its post-operative period would sometimes go on to develop or redevelop heart block, often suddenly dying. Back in 1954, Paul Zoll and his colleagues in Boston, Massachusetts had used electrical stimulation to overcome heart block in patients. They'd place electrodes over the heart to transfer electrical currents from a large box. The name of this instrument? A cardiac pacemaker. In mid 1957, Lillahei, with the aid of Medtronic, made an improved version of earlier pacemakers for his patients. But despite outshining its predecessors, it still had quite a few flaws. One such fault was the fact that they still required power outlets. This worried doctors as no power meant no worth. October 31st that year, a storm hit the Twin Cities, causing an hour-long power outage. For most residents, It was a nuisance. For the blue babies hooked to those pacemakers at a UMM's hospital, it was life or death.
Then there was a power failure at the University of Minnesota in October of '57, and the machines that were plugged into AC power failed, and they lost one child that was on an AC machine. And following that, Dr. Lillahai came to me and said, "Isn't there some way we could have a battery backup for this pacemaker?" I went back to our garage to put together the pacemaker for the kids.
Bakken spent the next 4 weeks in the Medtronic garage, working on it. His first attempt was to modify an existing pacemaker, but then realized that it was quite an insufficient way to fulfill Dr. Lillahai's request. He tried again, this time designing a new device altogether, which drew inspiration from a circuit in a magazine, creating the world's first wearable battery-powered pacemaker. Pacemaker 5800.
And I came back to the hospital, and this pacemaker was attached to a child.
The pacemaker had immediately restabilized the heartbeat of that kid. That technology that created the pacemakers had another effect. The device could be adapted in new ways to suit different needs. This idea was first applied in early 1959 when Dr. Samuel Hunter and Medtronic engineer Norman Roth repurposed the pacemaker for Stokes-Adams disease patients, designing the Hunter-Roth electrode to focus the electrical currents. This caught the attention of Dr. William Chodak and engineer Wilson Greatbatch, who were gathering studies and reports from all over the globe on cardiac devices. By the early 1960s, all the research they had done paid off with interest when they and an associate, Dr. Andrew Gage, successfully implanted their device, the first implantable pacemaker, in 10 patients, several of whom lived for an additional 20 years. By the end of that year, their manufacturer already had 50 orders for the device, which was named the Chodak Greatbatch pacemaker. The succeeding decades brought numerous new instruments, several of which were also pivotal points in medical history. 1977, the Medtronic Hall prosthetic heart valve saved 305,000 patients incident-free. It was designed by Dr. Carl Hall and electrical engineer Robert Caister. In 1987, Medtronic collaborated with French doctors on the world's first deep brain stimulation system and consequent devices to treat movement disorders. 1993 brought implantable cardioverter defibrillators, or ICDs, which combined the most recent technology of pacemakers and current defibrillators. At this point, Medtronic has become one of the leading medical technology companies around the world. Now in the 21st century, electrotherapy, especially for the heart, is still on an intense development streak that started in the mid-1900s. Patient problems and consequent need is also on a rapid incline, due to reasons like pollution, food habits, and social pressure. Both medical technology as well as client demand still haven't shown any signs of slowing down. Today, the lives of over 78 million people have been improved by Medtronic, with more than 3 million having implanted pacemakers. That's 2 people helped every second. People get to live fuller, longer lives with their loved ones, with their family, their communities, because of that pacemaker. And that literally has happened millions of times since 1957. And to think, none of that would have happened if not for thousands of people around the world who made it their mission to help patients of the heart. But that's the past. What's in for the future? As of now, Medtronic is working on micro-sized pacemakers. The same technology that made up the pacemakers before it are inside this one as well, except miniaturized, allowing the micro to be the size of a coin. That's not all. Rapidly growing gene editing tools are causing speculations in medical organizations across the board. Speculations saying that sooner or later, in 20 to 30 years, we won't need pacemakers ever again.